Today we're doing set notation, and set is just kind of sets are just a collection of things, and there's a couple ways you can write them. They call this first one set builder notation. Set A is equal to X, where X is American colors. Okay, so X represents all American colors. Another way you could write that is just write the list though. So what are the American colors?
Red, white, and blue.
Red, white, and blue. Now, we're going to have to write a few sets. I don't really care. Some people have trouble with these braces. So if you just want to use parentheses, that's fine. Not a big deal. Not all my braces are pretty either. But these are the same thing. This is called set builder notation. A is made up of X, and then it describes what X is. And then the other notation is just list them out, make a list. Okay, sometimes you can't make a list because what if your set includes, let's say set C is, well, I guess you could kind of make a list. X, where X is even numbers. Now, can we make a list of all the even numbers? No, but you could. It would be legal to just go 0, 2, 4, 6, ... Okay, so even though that's an infinite list, that kind of implies all the. I guess that would be positive. Even numbers starting at 0. Technically, negatives are also even. Okay. Anyways, let's. The hard thing about today is each individual part's not hard, it's just that there's so many little things. And we're going to use set notation a little bit throughout this book, so that's why we're starting with this. But basically it's just a one-day thing, mostly. Let's say set B is some other colors, like what's your guys' favorite colors?
Green.
Okay, green, brown. I don't think I've ever heard anybody say brown is their favorite. Yellow. Okay. That's enough. We'll just stop there. All right. So. We need to start with first symbol that we're going to start with is this symbol. It kind of looks like an E-ish, but it's not really. I don't know if I can draw it any much better than that. This means an element of. So red is an element of set A. So it just means it's one of the things, one of the members of that set. Okay, is red an element of set B? No. So the fancy way of writing that is putting the element symbol and then just putting the slash through it. So that just means it's not an element of set B. Got it? So that's symbol number 1. There's a bunch. Okay. Equal. Okay, guess what it means for sets to be equal?
Same thing.
They have all the exact same elements. So are sets A and B equal?
No.
No. So you would say they're not equal. What page are we on? 4. Right at the beginning. However, though those sets are not equal, they are equivalent. And the only thing equivalent means is they have the same number of elements. Okay, so set A is equivalent to set B because they just both have 3 elements. There's no symbol for that. Okay, they just are. All right, next. Okay, this symbol means a subset. Do you guys remember what the natural numbers are? you guys remember what whole numbers are? Yeah, that's right. You guys, good job. You guys remember some stuff. Okay, well, both of these sets are infinite, but the natural numbers you could say are a subset of the whole numbers. What do you think that means? It means every element in the natural numbers is also in the whole numbers. Okay? A subset could, you guys, when we do less than, what's this symbol right here usually mean? Equal to. So that's kind of what this line right here means. It means a subset, they could actually be equal. So they're not quite equal because this doesn't have a zero, but they could be. So if the two sets are identical, if sets A and B were identical, you could still say that A is a subset of B. Okay, because this means they could be equal. Okay, if they don't have that symbol underneath, this is called a proper subset. And it's proper because it's just not equal. Sub kind of means less than, right? It's below. So if it doesn't have a line underneath, that's called a proper subset. That just means that they're not equal. And set in the natural numbers is not equal to set W, the whole numbers, because n does not include 0. Therefore, n is a proper subset of the whole numbers, W. Does that make sense? No. Okay. So, subset, this is what this symbol means. Just means that everything that's in n is also in W. It could also be equal. The sets could be equal. That's what this line down here means. If there is no line down here, that's called a proper subset. That means they're not equal. And these two are not equal because this contains 0 and this one doesn't. So basically, this set has elements that this one doesn't, or at least one. Okay? All right, we're getting there. We're almost. By the way, everything, all these symbols, you can put a slash through it. So if you want to say n is not a subset of W, like earlier, A, my red, white, and blue, and what other were the other colors were, those were not subsets of each other, so you could put that slash through it to indicate that they are not. Okay. You can use not. All right. What were the colors? I should probably rewrite them. We had red, white, and blue. I'm just going to abbreviate. Let's just call it red, white, blue. What were the other colors? Green. Well, brown we'll call BR because that's blue and yellow. All right. Another symbol is this. It looks kind of like a U, but it's called a union. Have you guys done this before? Probably not. A union just means everybody's invited. So a union of these two sets would be red, white, blue, green, brown, yellow. If there's a repeat, you only have to write it once. I mean, you can only be a member of a set once. But union means everybody's united. Everything gets to come. Red, white, blue, green, brown, yellow. Okay. So union is like, see how it's kind of like open arms? So, oh, that's inviting. Okay, this one, not open arms. This is called an intersection. Okay, intersection means, it's kind of like the word and, it's only what they have in common. It's got to be in this set and this set. So, what do sets A and B have in common? Nothing. Okay, from last year, when we had an answer that was nothing, you remember what we put? Yeah, no solution, or it's also called the empty set. Okay, so this is also a symbol for sets. It just means nothing. So if you do the intersection of A and B, they have nothing in common. This is how you would write it. Okay, union invites everyone. Intersection only is exclusive. Only the elements that exist in both. So if I had like C is 1, 2, 3, and set D is 2, 3, 4, what would be the intersection of those two? Yeah, they both have 2 and 3 in common. So the intersection of C and D is 2 and 3. Okay? Did we get them all? Oh, one left. Actually, there's kind of 2 left in a way. There's something called a universal set. And it's kind of a defined set, like whatever universe you want to live in, that's, you kind of define it, or the book defines it, or whoever defines it. So let's say our universal set is X, where X is between 0 and 11. Okay, so let's say our universal set, like every number that we can choose from are numbers between 0 and 11. So in other words, it would be like 1 through 10, right? Okay. If I say set A is 1, 2, 3, 4. Okay. Here's my last symbol. It's kind of like an accent. It's called the complement of A. It means everything that's not in A, but still in the universal set. So what is not in A?
5, 6, 7, 8, 9.
Right. I'm not very good at it either. So yeah, what would not be in A is doesn't include 5, 6, 7, 8, 9, or 10. Now, I could keep going except for the universal set I defined between 0 and 11. So it's got to stop at 10. Does that make sense? So the complement of a set is whatever's not in that set, but still fits inside whatever the bounds are. Okay, that is everything. I know it's a lot, but we'll go through it again as we go through these odds. Try to get it all mapped out. Okay, number 1. Set L equals X, where X is a letter in the word grace. So the directions say describe each set using a list of its elements. So in other words, we're just going to put it in list form. So what are the letters in the word grace?
G, R, A, C.
Yeah, we're just going to write them as separate elements. So we're just putting it into list form. So number 2 is going to look something like this. I think number 2 was the American flag colors. Yeah. Okay, but number 2 should look like this, except for it should be colors. Okay, number 3. Describe 2, 4, 6, 8 in set builder notation. Okay, on this one, you always put like a little letter here. I always just use X. And then you describe what X is. Okay, so how could we describe 2, 4, 6, and 8?
X is an even number greater than 0 less than 9.
Yeah, even numbers between 0 and 9, or you could say 0 and 10 or whatever. That's fine. X is an even between 0 and 10. Okay. So number 5, I'm not going to write this down. It would take me too long to copy all this. We got to say if they're equal, equivalent, both, or neither. It's kind of like multiple choice. Are they equal, equivalent, both, or neither? So are sets A and B equal? No, because they're not the same. Are they equivalent? Yes. Because equivalent just means they both have the same number of elements. They both have 3, so they are equivalent. Equivalent just means the same number of elements. Number 7, are sets G and H, are those equal? Yes. Are they equivalent? Yes. The order in a set doesn't matter, by the way. Probably guessed that. But so they're both equal and equivalent, so all you have to do is write both. Yeah, number 9. Are those Santa Fe, Boise, New Mexico, Idaho, Virginia, are those equal?
No.
Are they equivalent? No. So it's neither. Okay. Number 10, 11, translate each sentence into symbolic notation. So rewrite it in symbols. So number 11, B is an element of K. You guys remember the element of symbol?
It's like a C but with an E.
Yeah, kind of E-ish, kind of long. So B is an element of K. All these symbols, if you didn't take notes, they're somewhere in your book on page 2, 3. "13. The set containing K, L, and M is not a subset of T. Okay, so I need a set containing K, L, and M. Okay, do you guys remember the subset symbol?
Is it with the underline on it?
Yes. But it said it's not a subset, so you just put
Cross
a
it out.
cross out of set T. Not a subset. Okay, so, by the way, I don't think I mentioned this. K could be in T, but it's still not a subset if not, it has to have all 3 of these are in T for this to be a subset. All the elements have to work. Okay, 15, translate the symbols into written sentences. So we're doing it the other way. 15 is almost the same as 13, we're just going backwards. So, a set containing A, B, and C, is that how they said it on 13? Yeah, set containing A, B, and C. Okay, what was that little movie thing?
Element.
No, that was the E one, that's an element. Proper subset. Did they cross it out? I forgot.
Yeah.
Okay, so is not a proper subset of what? D. Of set D. It's basically 15 but backwards, almost. Anyway. Or 15 is 13 backwards, that's what I meant to say. 13, no, 17, yes. Okay, what did this symbol mean? What did we call that? Well, it was no solution last year, but what did I call it at the beginning of the class? Do you remember? The null set. Or you could call it the empty set also. This means nothing, it's blank, it's empty. Let's see what to say. Okay. This U that they wrote, I kind of mentioned it, but I didn't point it out. The U that they wrote there actually stands for the universal set. Okay, so the empty set, what's this symbol mean?
Not a subset or subset.
Is a subset of the universal set. So yeah, you're only supposed to use U when you're talking about the universal set. Probably should have put the empty set. You could also call this the null set. All right. That was 17. 19. True or false? Let's talk about 18. 18 is a kind of a tricky one, so let's go through it. So 18A, these are just true false. Is the empty set a subset of 1, 2, 3? Yeah. A subset just means are all the elements in this set in this one as well? What do you guys think? It's kind of a weird question.
True.
It's true. B, is the empty set a proper subset of ABC? That is also true. A proper subset just means they can't be equal. Which they're not, so that's also true. It's almost the same as A. C, is the null set a subset of the empty set? Is an empty set the subset of an empty set? It's true because remember subset can mean they're equal. So the empty brace is another way of saying the empty set. Okay, they didn't put anything in there, so that's, these are the same. Okay, empty, null, nothing in either of them. Okay, D, is the empty set an element of 1, 2, 3, blah, blah, blah? No, yeah, a set is not an element. So that's just false. 19, true or false? The empty set is a proper subset of every set. That's a trick question. That's why we're doing 18, 19. These are kind of trick questions. It's false because this is the one example. It's kind of saying this. A proper subset has to have fewer elements. So these are not fewer, this is like equal to. So it's not a proper subset because the empty set is a subset of itself, but it's not a proper subset of itself.
Still false.
Yeah. Okay, number 20, 21. Draw a Venn diagram. Do you guys remember what those are? It's not necessarily a math thing. Circles, pictures. Illustrating the relationship between the sets. State a universal set, probable universal set. Okay. Okay, this is false. 21. So we need a circle for set L, a circle for set M. Do set L and set M have anything overlapping? Anything in both? What is it? Kansas. So Kansas is going to go there. I'll call this set L, set M. So we don't need to write Kansas again on set L. We just need to write Kentucky. And we don't need to write Kansas again for set M. We just need to write Alabama, Arizona, Arkansas. Okay, what is a possible universal set that these guys are living inside of? Like, what's the subject? What do all these elements have in common?
States.
Yeah, they're U.S. states. So that's part of that's another question they asked us. What might be the universal set? Like, what might they be choosing from? The answer is U.S. states. All right, 22. Any questions? Okay, if you have questions, you can ask them individually. After I cut you loose, we're getting kind of close to getting to the end here. Oh, shoot. This class is a little bit shorter than normal classes. Okay, 23. M and P. What do M and P have in common? 3 and 5. So, how are we going to do that if the only thing in P is 3 and 5? Well, just going to do that. 3 and 5. What else is in M? 2, 4, 6. I probably shouldn't put a comma. Okay, there's nothing else to put in P because it only has 3 and 5. Okay, what could be the universal set that we're drawing from here?
Natural numbers.
Yeah, I would put natural numbers. Natural numbers like 1, 2, 3, 4. You know what? Let's just go to 27. Those last ones are. Hey, I tell you what. I'll make 30 a bonus. Okay, 30 is very difficult, so. Let's just go to 27. Yep. I'm not done yet. We're still on 20. What number are in 25? Okay, do you guys remember what that U symbol meant on 25? Remember what this symbol meant? Union, which means everybody's invited. So we're just supposed to make a list of everything in set A and B together. So A is 1359 and B is 2379. I'm going to put them in order, not that it really matters, but so we have 1, 2, 3, 5, 7, 9. Did I miss any? One, two, three, 5, 7, 9. I think, yeah, that's all of them. 27. Okay, so in parentheses it has A intersection B, but then it has a little asterisk looking dealy up here, which means not that. So let's start with what's in parentheses. What's the intersection of A and B? What do A and B have in common? 3 and something else. 9. Okay, but that's not the answer. Okay, this little symbol, I think it's more like an accent symbol than like apostrophe, but anyways, doesn't matter. It means what's not in this set. Okay, the universal set, we got to read the directions. It says, well, where are we at? The universal set is natural numbers. So basically our answer is all the natural numbers except for 3 and 9. So we're not using 3 and 9. So our answer would be 1, 2, skipping 3, 4, skipping 9, dot, dot, dot. All right, still got 11 minutes.
What is the dash mean again?
Okay. It means, it's called the complement of this. It means whatever's not in this set. It's kind of like the opposite. You have to know what the universal set is though. So the universal set was in the directions, it said the natural numbers. So whatever's not in this set but still a natural number. So here's my answer. Notice I didn't put 3 in there
Yeah.
and put 9 in there. And I had to put dot, 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 because natural numbers go forever. Huh? 9?
We're not doing the Venn diagram, all that stuff.
Oh, no, yeah, let's skip the Venn diagram, that'll take too long. Just do the Venn diagram on the 2 that we did it on, 20 and 22. We'll call that good. I knew that would probably take us a while.